Okay, let's continue where we left off around section 3.2. I want to take a look at the bond pricing. So we're going to find out the bond price using the compound interest formula. So this is where compound interest formula is going to be. But first of all, let's take a look at the definition of the bond. The bond is a fixed income instrument that represents the loan made by an investor to a borrower. So basically, the investor lend money to the companies or government agencies so they can fund the projects. And typically, the investor lend money to either the corporation or government. The bonds are used by companies, especially public companies, public trading. The federal government, state government, local government, and they all use the bond to finance the projects and operations. And owners of the bond are called debt holders or creditors of the issuer. Right? Debt holder or creditors, right? Owner of the bond. So investors loan money to the company or government, and they typically receive a certificate indicating the companies are borrowing money from investors. And zero coupon bond is one of the very special bonds. So zero coupon bond doesn't pay interest, right? But instead, the company or government give a deep discount, give a big discount when the investor purchased the bond. So for investor, they have a profit at the maturity, right? So meaning by the time the bond matures, the company or government pay back the loan, then the investor will have a profit based on because they get discount when they purchase the bond. And again, when the bond is mature, then the bond could be redeemed with full face value. Face value is when the bond is matured, the price of the bond, right? So typically, this is an important term. It's also called par value. Par value is the same. Now, notice that zero coupon bond is a debt security instrument. Does not pay interest. That's one of the important feature. Secondly, zero coupon bond trade at a deep discount, offering full face value at a maturity. The difference between the purchase price of the zero coupon bond and the face value indicates investor's return. Okay. So again, we are using the compound interest formula to find out the bond price right now, and then the difference between the bond price right now and then the maturity and then the face value. That's what they call the interest, or you can call that return for the investor. Now let's take a look at this example here. So as you mentioned, we are using the compound interest P times then T. So this is compound interest formula, and we are using this to find out the present value of this bond price. So looking for P, right? So basically, how much would a zero coupon bond cost that matures in 10 years? And here 10 years with face value. That the face value is redeemed at the maturity date, meaning after 10 years, the investor get back $10,000. So this $10,000 is the value of the ending balance. That's $10,000. And in the bond market, has priced to yield 5.25%, assuming yearly compounding. So 80 years, 5.25%. And then number of compounding periods, compounding yearly, so once per year, right? So n equal to 1. Right now, the only thing we don't know is the present value, but the principal in this case would be the present value of the bond. And we solve for that. So here you go. So we apply the formula here. Our n to AT. Now A is $10,000. P that we're looking for, and that's 1 plus the rate is 5.25% over 1, and raised to n is 1 times 20 is 10. Okay. So we're gonna simplify a little bit. 10,000 present value times 1 plus 5.25% over 1 we get 10 over 10. Right? So you divide both sides of the equation by the exponent 5.25% to the 10th. And cancel that, and then present value is by itself. So P by itself is equal to 10,000 over 1 plus 5.25% to the 10th power. And let's see what that is. So again, we are using Excel to do the work. Okay, so here we go. So we put in the equal sign. Now we have 10,000 dividing by 1 plus 5.25% raised to the 10th power. You can also turn 5.25% into decimal number, equally good. So we end up with $5,994.86, 5994.86. So 5,994.86. 594.86. So this is the price of the bond. So remember, investor only paid $5,994.86 right now. But in 10 years, investor is getting $10,000 from the company. Is the return on investment. For the investor, by lending the money, they are getting return $10,000 in 10 years. Minus purchase price $5,994.86. So this turned out to be $4,005 and then. And this is the total return for the investor. So this is how the zero coupon bond works, right? Taking a deep discount when they purchase the bond. So example number 2, what is the price of a zero coupon bond with par value $8,000? So face value $8,000. Then matures in 20 years, compounding monthly if the bond is priced to yield 5.75%. So again, this 8,000 is any balance or the future value $8,000, okay, in 20 years. And so time to yield 20 years. Compounding monthly indicates n equal to 12. The compounding period per year is 12, and then the rate is 5.75%. So now we are using the formula to solve for the present value. So A equal to P times 1 plus our n to T. So throwing all the numbers, 8,000 future value, present value P 1 plus rate is 5.75% over 12 raised to 12 times 20, and that's 240. And we can just divide both sides of the equation by the exponent. 1 plus 5.75%. over 12. Just rewrite it in a second. 5.75% over 12 raised to 12 times 20, that's 240 power. So divide that from both sides of the equation. So we cancel this. So present value is by itself. So P is equal to 8,000 over 1 plus 5.75%, 12 raised to 240 power. And let's see what that is. So let's into the Excel. So we get that is equal to 8,000 by 1 plus 5.75%. 75% over 12 raised to 240 power. Let's see what that is. It's the $2,540 and then 6 cents. $2,540 and 6 cents. Okay, that will be the price of the bond right now. $2,540 and then 6 cents. Okay, and as you can see, investors getting $8,000 in 20 years. So return on investment will be $8,000 minus $2,540 and 6 cents. So the difference is what we call a return of $5,459.94. Okay. That's total return for the investor, right? Okay. And now let's take a look at this. So this is a follow-up question. Consider bond in example 2. So same bond with the face value $8,000, and then 20 years, compounding period 12, right? Now the only thing difference is the interest. Now the prevailing interest rate for competitive investment increases, so the market prices the bond to yield 6%. So it means rate equal to 6%. So that's slightly different interest rate. So R equals 6%. Now how much is the bond worth right now? So one more time, we're solving for P, right? So it's going to be P equal to A over 1 plus R over N to the NT. So you can directly jump to this and get P by itself. Now we throw in all the numbers, 8,000 over 1 plus, rate is 6% over 12, and raised to 12 times 20, that's still 240 power. All right, so now let's put into the calculator, Excel, get a result. And let's compare all these different options here, see how the interest rate have impacting the bond price. So this is equal to 8,000 divided by 1 plus 6% by 12 and raised to 240 power. Everything else is same except the rate. So now the bond price is cheaper because it's, the bond price is cheaper, meaning investor getting more return because the interest rate is higher. Interest rate is higher, meaning investor is getting more return. So that's why the bond price is $2,416.77, which is cheaper than the first option. So $2,416 and 77 cents. And then one more time, total return on investment. So this is the bond price. Bond price only $2,416. $216.77. And total return. So for the investor, they're getting 8,000 in 20 years, but they only paid $2,416.77. So now the total return will be 8,000 minus $2,416.77. So this turned out to be $5,583.23. And that's total return on investment, which is slightly better than the previous option. Now let's look at the third option, determine the value of the same bond in example 2, price to yield now is 6.25%, so everything else is the same $8,000. Time is 20 years, and then N to 12. So we're still solving for P, so P equal to future value A over 1 plus L of N. And one more time, we throw in everything 8,000 over 1 plus the rate is 6.25%. So it's 6.25%. 12 raised to 12 times 20. Let's see what the bond price is right now. When interest rate is higher, our intuition should be the bond price is lower because investors getting more return. So 1 plus 6.25% by 12 and raised to 240 power. And this result turned out to be $2,299 and then 2299.49. 2299.49. And this is the bond price. Now one more time, we're looking at the total return here. Total return should be $8,000. Remember, investors getting more returns here because the bond price is cheaper, slightly cheaper. So this turned out to be 5,700 and then 51 cents. And compared to the previous one, it's slightly better, right? So investors getting more return. So summarize what we have here. When the interest rate is higher, the price of the bond will be lower. When the interest rate increases, then the bond price decreases. You can easily just get all these bond price here from Excel. And the first bond price is, just try to copy these three here. So as you can see, as the interest rate increases, the bond price decreases. Okay, so we get that. So that's exactly matches with our intuition. So for investors, it's better, right? So this decreases. Interest rate increases, bond price decreases. Okay. So now last example number 5, a zero coupon bond that matures in 15 years. So time t is equal to 15 with a face value $20,000. So face value equal to 20,000. Okay. So now it's available from the bond dealer for $13,800. So that's the present value of the bond, $13,800. And then we're looking for the interest rate, and then compounding period is 12. And then the only thing we don't know is rate. We're solving for that. So now we apply the formula one more time. P times 1 plus R over 10 to T. Replace everything, 20,000 goes in there. Present value is 13,800. Plus rate Rate is what we're looking for, out of 12, and that's 12 times 15. 15 is 180. So if you're dividing both sides of the equation by 13,800, okay, drop that, so you get a 1 plus r over 12 raised to 180 power, that's equal to, I can simplify a little bit, drop a couple zeros here, so you get 200, 138. In order to get rid of the power here, we will raise the reciprocal power of 180 power raised to 1 over 180 power. So this 238 raised to 1 over 180 power. So now this inner power and then the power outside offset each other, we end up with 1 plus r over 12 equal to 200 over 138 raised to 1 over 180 power. And you have to solve for r, subtract 1 first. So get r over 12 equal to 200 over 138 raised to 1 over 180 power minus 1. Now in order to get r by itself, we multiply 12 on both sides of the equation to get a result. Okay. So it's also algebra. So here rho r is approximately that. So let's put into the Excel value of r. So we have equal to open parentheses. So we have 200 over 138 and raised to 1 over the 80th power and minus 1. Close parentheses and multiply by 12. This will give us a result. And again, we run it 4 decimal places. So go down to 4 decimal. So it's 0.0248. 0.0248. That's the interest rate we're looking at. So 0.0248. That means 2.48%. So the rate is 2.48%. And that's pretty much everything on this section, remaining section.